EnerCalc 3D has a useful tool to simulate moving loads by automatically creating many permutations of a load pattern along a line of collinear members. In order to demonstrate its use, first what I'd like to do is show that I have some load cases defined, and I'll mention that it's the live load case that contains these point loads that you see out here on the first girder. Also, if I come to load combinations, I want to mention that I've pre-populated this model with generated load combinations, and that'll come into play at the end. To generate these moving loads, we need to select all of the members that we want to have affected, and then we can come to Create tab, Generate Loads, and down to Moving Loads. In the Moving Load dialog, first we select the load case that contains the loads that we want to have generated. That's our live load case. Then we can specify the move step. In this case, I'll leave it set to 1 foot, so it's nice and small, and we're sure that we find all possible positions of that loading with respect to the supports. The table lists the members that we've selected, and the controls allow us to alter that list if we want to once we've started the command, but I've already selected all of those members, so I'll just go ahead and click OK. In a second, we see all of those loads generated, lots of incremental steps all along that beam. I'll come to load cases so that we can point out that we still have our original live load case, but notice that there are many additional load cases that have been generated, all of the live load type, and they indicate what step they're associated with. And then if I come to load combinations, and this is where we'll see the real power of this tool, not only do I still have the original load combinations that I created, but if I scroll down, notice that it's worked through the permutations of the original load combinations to incorporate every one of the steps. So every original load combination now has all of the steps that have been generated. Quite an extensive list of load combinations here, but it saves us an immense amount of work that would otherwise have to be done manually in order to ensure that we find all possible loading positions and worst case effects for shears, moments, and deflections.